Good day everyone, here's our math challenge for today. And here's our question. What is the value of floor of square root of 6 plus square root of 5 raised to 6? Now take note that this notation floor of x denotes the greatest integer not exceeding x. Now, if you want to try this problem, just pause this video. You have 20 seconds and timer starts now. Time's up. Now let's answer this question together. To answer this question, what we're going to do is to let this number square root of 6 plus square root of 5 be equal to a variable a. And the trick to this kind of question is to introduce another variable which is equivalent to square root of 6 minus square root of 5. And the question is why we choose this number square root of 6 minus square root of 5. First thing is square root of 6 minus square root of 5 is the conjugate of our original given. And also take note that square root of 6 minus square root of 5 is between 0 and 1. And also, if that number is raised to a positive power, the result is still between 0 and 1. This is very important later on. So now, let's answer this question. First thing to do is to get these two equations. And then what we need to do is to add the value of a and b. Now notice that square root of 5 and negative square root of 5 cancel out, so the right hand side is just 2 times square root of 6. Now let's set aside this result. Now instead of adding, let's multiply these two equations to get the value of a times b. Now notice that on the right hand side, we can apply the special product, and it is equivalent to square root of 6 quantity squared minus square root of 5 quantity squared. And this is simply 6 minus 5. And 6 minus 5 is just 1. Now, let's set aside this result. We have the value of a plus b, and we also have the value for a times b. And take note that we want the value of a raised to 6. Now, to achieve that, we will use this identity. We have a cubed plus b cubed. It is equivalent to a plus b raised to 3 minus 3 times ab times a plus b. Now notice that we have a value for a plus b and a times b. So let's substitute those values. We have 2 times square root of 6 cubed minus 3 times 1 times 2 times square root of 6. Now let's simplify. 2 times square root of 6 raised to 3 is equivalent to 48 times square root of 6. Now the other term, 3 times 1 times 2 times square root of 6 is just 6 times square root of 6. Now simplify more. This will give us 42 times square root of 6. Now we have now a cubed, but we need a raised to 6. So let's square on both sides. Now the left hand side is just equivalent to a raised to 6 plus 2 times a cubed b cubed plus b raised to 6. Now let's focus on this a cubed times b cubed. This can be written as a times b raised to 3. Now, let's subtract 2 times ab raised to 3 on both sides. And now, let's simplify. 42 times square root of 6 raised to 2 is equivalent to 10,584. And take note that a times b is just 1. So the right hand side is just 10,584 minus 2, or simply 10,582. Now also take note that we want the value of a raised to 6. So let's subtract b raised to 6 on both sides. And now, let's take the floor value on both sides. Now take note that this a is square root of 6 plus square root of 5. Therefore, the left hand side is just the floor value of square root of 6 plus square root of 5 raised to 6. Now here comes the exciting part. Take note that this b is between 0 and 1. And also take note that if we raise this number to a positive integer, the resulting number is still between 0 and 1. Therefore, the value of b raised to 6 is between 0 and 1. Thus, the number on the right-hand side is a bit less than 10,582. Therefore, if we get the floor value of the number on the right-hand side, this will give us 10,581. Therefore, the floor value of square root of 6 plus square root of 5 raised to 6 is simply 10,581. And, as always, we are done.